Hi everyone, this is Angela Ochu-Baiye and you're welcome to Across Borders with, of course, Angela Ochu-Baiye. How are you guys doing? I'm so excited and happy that you joined me today. We had a crazy start, but I'm excited that I'm here with you today. Okay, so remember that you can click on the share button whether you're on Twitter or on Facebook and let everyone know on your platform the conversation that we're having right now. So I have the honor and the privilege of introducing to you someone I met on Twitter, and we have actually been chatting from Twitter and then on WhatsApp, and eventually today I got to see him, of course, face to face virtually. And we are going to be having an amazing conversation that has to do with how vaccines work and the three available for COVID-19. Now, before I bring him on board, because he's already in the studio, he is Robert Swanda, and he is the fifth year PhD candidate at Cornell University, USA. And his research basically investigates how to best design mRNAs for cancer therapy. And he is extremely passionate about communication and public presentation. And he's used this to describe the SARS-CoV-2 vaccines to the public. That's how I actually got to meet, or I got to know about him through one of his videos on Twitter. So I am bringing him in the studio right now, and that is Rob. Hi, Rob.
Hi, great to be here.
Awesome. Finally, we're doing this.
Yes, thank you so much for having me.
Thank you. Thank you. So I was just saying to my guests or the videos that you put out. How did you start to put out these videos though? When did it happen?
Yeah, so
Or
I
why did it happen?
yeah. So I have been working with RNA for the past 5 years here at Cornell,
Mhm.
and my parents were reading about these vaccines that were coming out from Moderna and from Pfizer, and they were like, "Oh, RNA, you work with that, right?"
Yeah.
And they're not scientists, so I told them, yes, of course I work with that. And they said, well, how does this vaccine work? Is it safe?
Mhm.
We're a little scared. So I was on them on the phone and with a piece of paper just trying to describe to them how these vaccines work.
Mhm.
And by the end of it, they were like, we get it. Oh my gosh, this is so cool. And then they asked, is there a way that you could make a video? Because we're getting lots of questions from our friends and
Yeah.
from other family members who know that you're a scientist, and they wanted to share the video or the
Mhm.
information that I had shared with them to other people.
Mm.
So I made the video one night, like in my lab. One of my friends had helped me make it, and then I sent it to them and was like, okay, like I'll post it online. I
And
posted
let's
it
see
on
how it's gonna go.
yeah, I posted on Instagram. I posted on Twitter. I only had like 100 followers, so I was like, well, if maybe if half, if 50 people watch it, like that's great. And then it just, every hour it just kept getting more and more and
Increase it.
more popular.
And all the way from Africa, I got to watch the video and I'm like, oh, okay. I think it's making sense. I'm not really sure about this part, but I think if I engage more of the videos and I thought it was very interesting, which is why I reached out to you to say, okay, let's just have this chat. And
Yeah.
one of the reasons why I'm doing this, of course, I've already discussed this with you, is because at least part of my audience are a bit confused about how vaccines work and also the available vaccines that we have right now. And there's several controversies regarding it as to is it safe, who is making it. I don't even want to tell you the other sides of it. Maybe we'll get to chat about it later on. And I found your videos very interesting, and I thought that we should, talk about this, like how basic
Mhm.
is the aspect of understanding how vaccines work, because I also feel like people mix up what a vaccine is
Yeah.
and looking at it as a cure for something. So is it, so let's just start first with what is a vaccine, like what is it?
Right. So a vaccine is just a way to give your body ingredients in order for you to make antibodies, which are a protection mechanism for
Mhm.
you to fight off either a virus or a bacteria in the future. So they're preparing you to look out for this pathogen, virus or
Okay.
bacteria. If you
Mhm.
ever see it in the future, then to destroy it and don't let it infect you and make you sick. So it's more of a
Okay.
protection mechanism rather than any type of cure mechanism.
Sure. So it's not a situation where if someone is ill, you give them the vaccine and then they're okay.
Right, right. So there's still some research going out there on whether people who actually have been diagnosed with COVID should get the vaccine. Right now, they are giving, if you have COVID, at least in the US, you can still get the vaccine. They've done this before in the past with smallpox. People who had smallpox, they gave them the smallpox vaccine if it was early on, and actually they had much more reduced symptoms than patients who did not. So it's not a cure for sure if you do have it, but it may be able to lessen the severity of the disease itself.
Okay, so let's go to how vaccines work in general. Okay.
Yes.
Can I
So
tell you
typically,
what I've been, okay, so first of all, did you take vaccines when you were younger?
yes.
Okay. So I did as well. So my parents, of course, gave me and my siblings vaccines.
Mhm.
I also, oh yeah, I've got two kids as well. I didn't mention that. I knew it. So my kids equally have took the vaccines, right? So generally, I am pro-vaccine. There's some people who are just not. They're not they're not. They don't like
Right.
vaccines. Yeah, but
Yeah.
I am pro-vaccine. But how does it work in general when
So
you?
Yeah, so traditional vaccines have been designed to either use a really weakened form of the virus or bacteria to give to your body. Typically, this won't allow you to get sick, but then your body sees this bacteria or virus that's really weak, it can't replicate, and it says, okay, that's not supposed to be here. They destroy it, and then they remember what it looks like in the future. So, therefore, in the future, if you do actually see a full on form of this virus, you already have those antibodies, you have that protection, you're ready to fight it off. Some other vaccines work in ways to give you just a part of the virus or an inactivated part of the virus. And essentially, it works the same way. It's just training your body in order to know what that looks like for the future in order to prevent any further infection.
So would you say that the different, I don't know, maybe the different producers of vaccines have different ways of going about how the vaccines work in the body? And would that also
Ye-
be based on understanding how the system works in general?
Right. So at the end of the day, the destination is the same for all these companies and all the different vaccines. They're just maybe taking different roads in order to get to the same destination.
Mhm.
So certain roads might get you there faster. You might be able to produce antibodies at a quicker rate, avoid a worse infection, and other vaccines might not have as strong of an efficiency. But yeah, the end goal for these companies is just to be able to put out a safe product that can prevent the future infection in the future.
Okay, so when we talk about, so I just want to just take us back just briefly.
Yeah.
When you look at the aspect of vaccines,
Hmm.
um, I think it was this question. Oh gosh, I think it skipped my mind. Come back to me. It had when we look at the aspect of vaccines, is it more of oh gosh, I can't believe this is happening to me. I had this perfect question for you, but let's leave that.
That's
Once I
okay.
remember it, I'll
It'll
get
come
back to
back
you on
to
it.
you.
Okay.
Yeah.
Oh yeah, I think I remember. It's still about the controversies. Now,
Okay.
generally, of course, I've had to, for example, I took meningitis, I've had polio, I've given my kids polio as well. And in Nigeria, for example, when children are born, there's certain vaccines you get to give them at different stages. I think the final one you get to do is like at 2 years old. And then you
Yeah.
have people saying that the vaccines that are given to children, for example, maybe in Nigeria or in Africa, are totally different from the vaccines given to children as well, or whoever in USA or other countries, right? would you say as well that the creation of vaccines are specific to geographical areas? Because that's also part of what's causing some of these controversies. So that's the first question to ask you. The second regarding the controversy, and I'll remind you, is why is there such a big thing regarding the COVID-19 vaccine? I mean, I think this is this disease is one disease that has caused a lot of controversies regarding vaccine. So yeah, two questions for you.
So the first question addressing, different areas getting different vaccines is just more so about the fact that certain viruses or bacteria are more prone in certain areas. So in, different climates, other viruses and bacteria can't survive. So we know that like people there don't necessarily need to take the same vaccines as others in different climates where where a certain bacteria or virus can thrive and really get people sick. You might experience that if you're traveling to, quite far to a different country or something. You might be required or recommended to get, various vaccines in order to protect yourself because you're transporting your body from one climate where you were never exposed to a certain pathogen, and now you're going to be in an area where that pathogen might be able to infect you. So it's really just about the protection. And then, getting them at different ages, definitely having the children get the vaccines young is more of a way to protect them from these vaccines from these pathogens that we know that can really cause havoc and, be very deadly to especially children. So vaccinating them young, having them produce this protection, these antibodies, and then allowing them to fight off this pathogen if they ever saw it in the future just gives reassurance to the parents that their child is going to be safe.
Okay.
Yeah.
So that's fine.
Yes.
That's on. And second part.
And then, moving into why like all the controversy can be happening for this vaccine. I think that people mainly were concerned with, how quickly that this vaccine was developed. We know that COVID-19 started to affect people in February, so almost around a year ago, earlier in some other countries. So these companies didn't really start making the specific SARS-CoV-2 vaccine until March or so. And then they really started rolling things out as the next couple months went on. They began their clinical trials, did their clinical trials for several months, and then were able to get that data this past fall. I think that the fact that it was done quickly is actually beneficial for us because they enrolled thousands of people across various different countries of different backgrounds, of different ages, with different comorbidities. Maybe they had other diseases, or maybe they were on certain medications. The only people that were excluded from these studies were individuals who were less than 18 years old and people that were on immunosuppressants. So they really did a great job at getting a variety of different people to test the effects of, how effective are these vaccines going to be. But, that data that data sometimes doesn't make it out to the general public. People just hear a vaccine is made, but they don't know that it has been tested very vigorously and on a lot of people. Yeah. So I think that's where some of the fear stems from.
Okay, I was going to ask you a question, but I think I'll leave that towards the end. We go straight to the aspect of the 3 vaccines that we have available right now. And I know I said 3, but you can let me know if it's more than 3 that is available, just in case I'm wrong. If you could just clarify who the producers of these 3 different vaccines are, and I don't know, what's the connection between one to the other? Yeah, so to start.
Sure. So I'm going to lump 2 of them into one category and then the other into a third or second category. The first 2, one made by Moderna and the second made by Pfizer and BioNTech collaboration. So these 2 vaccines focus on the RNA branch of your genetic material. So they provide you with a vaccine that has been developed to encode the mRNA for one of the proteins associated with the SARS-CoV-2 virus. But what does this actually mean? So what they're doing is they're going to give your body the instructions to make one of the proteins of the virus. Now, the virus is composed of 29 proteins, so you're not even getting a full virus. You're just getting the instructions to make one protein. You're not even getting that single protein. Your body receives the instructions and then starts building that protein. Then once it builds that protein, that's when your body begins to say, that doesn't look like something we've seen before. We know what our proteins look like. You know, we have proteins in our hair and our muscles and our eyes, and we are familiar with what all of those look like, but that is different. So when they notice that it's different, then that's when they're going to mount an immune response, which is when your immune system comes in, destroys that foreign material or that protein that you just made, and then it's going to send that information to your B and T cells, which are just part of your immune system, and they're going to remember what it looked like. So those cells are actually going to say, okay, we remember what this looks like. Now, if we ever see it in the future, we're going to start dividing and we're going to attack it before it ever has the chance to infect us.
Okay, so let me hold you up there. You mentioned you mentioned that this and this is one of the vaccines, right?
This is two of them.
Two. Okay.
Yeah.
So you mentioned that the vaccine is not giving you the full virus. It's just giving you one part of the virus, which is one of the proteins, right?
It's actually not even going to give you the protein, which is really cool. It's just going to give you the instructions. The way I like to think about this sometimes is like, say you wanted to make a meal from somebody, your neighbor or a family member. They're not going to come and give you the food. Instead, they're going to come and give you the recipe. So you have to use your own ingredients and then make that food.
Okay,
so that's what this is doing.
Can I take this with a general knowledge of how I know vaccines work? So, I mean, from what we've been told, they kind of like put the virus in you or the bacteria in your system, and your system builds an immunity against it or fights it. And then if it pops up again later on, it kind of like has already built an immunity.
Yes.
So are you saying that this version right now is basically going to be tampering to some extent with our own system?
No. So it's going to use our system. So it's going to use our system like workers, but it's not going to be able to interact with our own DNA. So that was one of the concerns that I saw a lot of people that were worried about, was because this is, coming in and giving you some genetic material. People were concerned, oh, is that going to affect our own DNA? And one thing, you hear the terms too, and it can be very scary for people that are not in the field. But actually, like, anytime you eat some food, like some fresh fruit or some fresh vegetables, you're actually eating those fruit and vegetables DNA. So, and you're not incorporating that. You're not becoming an apple or a carrot or a potato, right? So like, your body knows how to digest it, how to destroy it. We protect our own DNA. And
I see.
Yeah, so we're using that small instructions that we get from the vaccine to make the protein, but then those instructions, they don't last very long. Actually, in the lab, they don't even last more than 1, maybe 2 days, and then they're destroyed in the cell. Now, some researchers are suggesting that this could last up to a week, but it's probably much less.
Okay, so I had this conversation with a friend, and well, it's not about vaccines, but I just want to relate it to what we talked about, because I know people are listening. So what she was talking about, contraceptives, right?
Okay.
And so there are different kinds of contraceptives, of course, for females. I'm not talking about the male ones. And she was always opposed to the contraceptive that was hormonal, because she felt like it was going to tamper with her hormones, and then she starts to react and respond to the contraceptives in such a way that she's not exactly sure how it's going to work for her. So she would prefer to use the contraceptives that was not tampering with her hormones, right? and which was basically the regular IUDs. I know this is
Yeah.
weird. We're talking about vaccines, but I'm trying to relate it to this question regarding vaccines as well, because people felt like, okay, I don't want anything to tamper with my natural system, my DNA or whatever, and then before I know it, in 2 weeks' time or 1 year down the line, I start to behave or react or show some whatever. And that was the major thing. I'm not sure if it's because of the term DNA, mRNA. You guys
Yeah.
caused all of this because of the term. So you're saying that these two vaccines, they don't do that?
No, they don't.
Wow.
And, it's actually important too to recognize that, on one of my videos, I explain this. And if you're a visual learner, you could watch this, is that your DNA is protected in something in your cell called the nucleus, and proteins are made in another place called the cytoplasm. So these two molecules, you could say your own DNA and then this vaccine mRNA, aren't even going to be able to interact. So there's not even a chance for that to happen if it could happen, which it can't.
Okay, so that's the first two that you just described right now.
Yep.
For everyone watching, you can see that I put a link. I put a link on the screen towards so you can click on it. That's if you can click on it. I'm not even sure you can, but if you can, please click on the link and you get to see videos of Rob describing different themes regarding the vaccine. And you can, of course, follow him as well on at Scientist Swanda on Twitter. He's also there on Facebook as well to see some of his videos. Okay, so Rob, you talked about the first two. What about the third one? How does it work?
Okay, so the third one is designed by Oxford and AstraZeneca. And the idea itself is the same. So the pathway of we're trying to make one of those proteins, get our body to recognize that that protein isn't supposed to be there, and then make an immune response, that is all the same. But the way that it's delivered is a bit different. So the RNA vaccines, the first two that I discussed, are very unstable. RNA doesn't last very long, as I mentioned, in the lab. Usually in a day, it's gone. And that's one of the reasons why they have to keep the temperatures super cold. Now, we can make the molecule much more stable by actually turning it into DNA. Now, DNA is stable. It can be at room temperature for several weeks. And it's, that's easier for transportation, especially when we're talking about a global pandemic. So this third vaccine focuses on actually using DNA to give to your body that will then just go through an extra process of being turned into RNA, then turned into the protein. So that's the three branches. And I usually try to start out all my videos with that pathway, is that we're always going to move from DNA in our own bodies to make instructions called RNA, and then those instructions will make the final product, which is the protein. We can't go backwards. We can only go in that one direction. And this vaccine comes in at the DNA level. So it's giving us a much more stable molecule for us to work with, but we do have to go through some extra steps in order to make that protein at the end, which is, could pose certain challenges.
Okay, so now I'm confused slightly, but let me ask. That's fine. So you're saying the third one is DNA?
Yeah.
And the first two is RNA?
Yes.
Okay, so the first two gives instructions to my body to create the protein to fight against the virus.
Yes.
Right? Then this third one, this third vaccine gives. What's the third one?
Yeah. So the third one's going to give you DNA. Now,
DNA.
And the way it works is a little bit different. So maybe if once I explain the way the delivery, maybe let me know if this makes a little bit more sense.
Okay.
So the way that the virus wants to work is that a virus can't divide on its own. It can't grow and it can't reproduce. It needs a host. our body, our cells become that host. So when a virus infects us, the first thing it does is it releases its genetic material. Now, it does that because it wants to replicate. So what these companies did was they actually put the instructions in the form of DNA inside of a different virus, a virus called adenovirus. And this virus has been modified. So they actually took out the DNA from this adenovirus and they modified it so it can't replicate, it can't make us sick, and they put in some extra instructions on making one of the proteins for SARS-CoV-2. So then they can put it back inside the virus and then deliver that virus to us in the form of a vaccine. So the virus comes in, it infects our cells, and then it's going to release the DNA because it wants to replicate. And the first thing it's going to do, release the DNA will turn into RNA, and then the RNA will turn into protein. But those proteins are not going to be able to make a full virus, which is what it was trying to do. The only thing that it's going to do is make that spike protein found on SARS-CoV-2, and then our body will elicit the immune response, destroy it, remember what it looks like, and protect us from future infections. So in my video, I kind of tried to explain it like you have a donut filled with some type of filling, and you're taking out the filling from one donut and you're going to put in the filling from another one. Another way you can think of it is that you're putting a jacket on the SARS-CoV-2 protein in order to help it get there. So the jacket's going to help disguise it in order to get it to our cells. But then once it gets there, our cells recognize what that protein is to make an immune response, and then will ultimately make the antibodies that we need to stay safe.
Wow. Okay, so this vaccines the way you've tried to break down how these vaccines work for the three right now.
Mm-hmm.
What is the similarity between the way these vaccines work, that's the three of them, or the differences between the three of them and the other vaccines that we have always known about that we just didn't care how it works?
Yeah.
What's the difference?
Yeah. So the difference is here we are using now our own bodies to make these virus proteins. Before, in the past, that hasn't been done before in regards to vaccines. Now, this technology, especially the mRNA technology, people were concerned that it's new, and it's not a new technology. It actually has been used before in cancer treatment. I'm designing RNAs in order to fight cancer. Yeah. I've been doing that for several years. They've been using it for gene therapy. And now they've actually been able to take that technology, but apply it to a new system. And that's where the vaccines come in. One of the benefits of using this system by just giving us instructions rather than giving us the actual weakened virus is that it does help us do this at a much quicker rate. So before, you would have to grow up a lot of virus. You'd have to find certain viruses that are weak or that don't infect very well. That can take a long time. That's why some of these vaccines have taken years to develop, because they don't want to give people a sick virus, because then you're going to make people sick. You want to, you have to grow lots and lots of virus and say, okay, well, which ones are not very good, but they're still going to help make an immune response. So that process takes time. Growing the virus takes time, but here, because it's just focusing on instructions, we can design those completely in a lab, package them up, and then give them to our bodies.
Okay, fantastic. So I have more questions for you, but we just quickly take a very short break and we'll be right back. Okay, stay with us, everyone. Okay, you're still watching Across Borders. And I'm here with Rob, Swanda. I'm having a wonderful time. And for those of you watching us on Facebook and on Twitter, please remember to click on the share button. Remember that you can follow Rob there. on his social media handle as well. And I've just put that on the screen for you to see. And that's at Scientist Swanda. There's several videos he's made regarding the SARS-CoV-2 vaccine. So please take a look at it. You might not get everything like straight away, but if you watch it the first time, watch it the second time, you probably get it. And Rob, I was saying to why I asked you the question regarding what the difference between this ones that we have and the other ones. We didn't really care how they worked before. We just knew that, oh yeah, vaccines are coming out. I'm sure whoever produced it went through the right procedures and everything. We really didn't care about it. But suddenly all of these, information as to, our DNA, they're putting this particular virus and all of it's just basically getting us confused and scared as well. But which now leads me to the aspect of safety, because that is a big thing. When we talk about safety, you as a biochemist, as a pro-vaccine guy, however you want to look at it, how safe is this vaccine amongst the three? And when we talk about safety, what should we be asking? What's the right question to ask regarding safety?
Yes. So in terms of looking across all the clinical trials that these three different companies have done in order to come up with these three different vaccines, there has been no deaths associated with someone taking the vaccine. There has been some mild reactions, but most of these reactions are typical of any vaccine that you're going to get. So, if you think of getting a vaccine, it's going to be you're going to get a needle. It's going to go probably up into your upper arm. Some vaccines go into the leg. That's not the SARS-CoV-2 vaccine. But you're using a needle, you're breaking the skin, and then you're injecting into this vaccine. So that already is, damaging your skin. So you're going to have a small response there. You're going to feel a little pain. Just like if you were to fall down and you were to break your skin, there is going to be, some type of irritation associated there. Then when you actually get the vaccine, you might experience some redness or you might have a little soreness. That's actually a good thing because that means the vaccine is starting to work. It means your body has sent in white blood cells to the area to start destroying that, the material that has been made and is starting to make antibodies against what, the pathogen of the vaccine that you just got. So you might experience, a little bit of redness, some soreness in that area for maybe up to a day. And then, some of the clinical trials were specific to different individuals. Some people didn't feel very good until the next day. Like their body just kind of felt like they didn't feel like themselves or like they had like a slight headache. All of those things are just going to be different for each person, but nobody had anything life-threatening or severe that happened to them.
But did you get to watch the video though of this lady who fainted on live TV?
Yes.
And that was something like people were like, no, don't take it. You see, we said we're gonna. Yeah. What did you think about that though?
I think it ended up coming out that she had a fear of needles. So it was, that wasn't good. Of course, if you're scared of the needle or you're scared, of something, then you want to just let your, the person who's going to be giving your vaccine know. There's nothing, wrong with being able to question and ask, real good questions to say like, I'm scared. I'm feeling this way. How is this maybe going to affect me if I'm, I have a certain illness? I think that those things are definitely important to ask the person who will be giving your vaccine because you want to watch out for yourself too. And every person is different. But of course, like those type of things make for great headlines and they make the news so much quicker than, the millions of people that have now been vaccinated, and we've had very minimal, reactions. So, like one example that I can think of right now is there's a lot of people who are concerned with having an allergic reaction, and that's completely okay because just like any drug or any food, there's a potential that somebody could have an allergic reaction. But people don't necessarily always think about that when they're trying a new food. They might just think, oh, well, it looks good to me, I'm going to try it.
Yeah.
So, but they're more hesitant about this vaccine, even though the risk is super low. So,
Mm.
it's so low that actually it's about 1 in 1 million shots is that somebody would get like some type of allergic response.
Mm-hmm.
But those are with vaccine. That's with data with vaccines in the past, and some of those vaccines actually contained proteins that were associated with eggs or
I see.
other foods. Now, these vaccines actually don't contain those components because it's not
Ah,
a live virus. They don't need to keep it
exactly.
alive. Yeah.
Mm.
So those concerns are definitely, people should still address those concerns with their doctor to make sure that they're safe. But having an allergic reaction can also be pretty well maintained.
Okay.
Those things come on very quick within a couple minutes. They can be fixed by having epinephrine or an EpiPen,
Okay.
and we've known those for years. We've been able to protect people from the side effects of an allergic response. Unfortunately, the con of not getting the vaccine because you're scared of an allergic response is far worse, because we
Mm.
don't know how to treat COVID. We
Mm.
are seeing people die by the thousands every single day. We don't have good treatments for it. So knowing the risk and the benefit are very important for each person to make their decision.
Excellent. I'd like to just, I think there's a question that came through on Twitter. I just don't know why I can't show it on the screen here, but it's by Deem Ama. And she's saying that I have a dumb question for you guys. Can a vaccinated person still be a carrier of the virus?
Definitely not a dumb question. That is an
Okay.
excellent question. um, and the answer is yes. So you can still carry the virus. And the reason for that is because the vaccines are not like a bubble that protects you from the virus coming in, right? The virus can still, get into your nasal cavity. That's one of the reasons why it's going to still be important to wear a mask until we can get enough people vaccinated. And, from there, it's not like your antibodies are made in a sprint. They're kind of taking their time. They're in a marathon. They're going to make sure they're there, but they're going to get there and they're going to do their job correctly. They don't want to get there quickly and then, run out of steam and not be able to do their job. So the virus might have a chance to start to replicate. It might be able to start to invade some cells before those antibodies can come there and then neutralize it. You might never feel sick because it does take some days, and our data shows that it does take several days for you to even begin to feel symptoms of COVID-19. So while your body is destroying the virus and you feel fine, that virus doesn't necessarily mean that you can't pass it on to somebody who might not have the antibodies, and that person could get really sick or potentially die from it.
I
So
see.
definitely still important to maintain the social distancing and the mask wearing as best as we can, in order to wait until we can get enough people vaccinated that we can eliminate this virus from the community.
I see. Okay, so that's
Yeah.
definitely not a dumb question. That was a very good
No,
question.
no.
So if we've got more questions on Facebook and Twitter, please send them in. I'm just trying to monitor to see where they're coming through. Hopefully would be done with this conversation in the next 15 minutes. So send your questions and your comments quickly. Okay, so another thing I'd like to look at is you try to describe the aspect of safety by saying, oh yeah, of course, you put the needle and the vaccine
Mhm.
goes into your system. So there's this,
Yeah.
especially here in Nigeria, there is this controversy regarding the vaccine and like stating that the vaccine is going to be like a chip being implanted inside of you. I'd like for you to
Yeah.
give me your thoughts regarding that.
So, yes, I have heard those concerns and that controversy. Um, And it's just, it would be impossible to have some type of chip made into a liquid and then have that liquid put in so small that you couldn't even see it, and then, go into your body. So, that idea is, I think it's just rooted in propaganda. It's not rooted in any type of science that, we could even be able to do that. It's a very futuristic idea, and I don't really know where it stemmed from or where it came from, but it's definitely gained a lot of concern from people. And
But you're saying
it's
it's futuristic. You're saying it's futuristic, meaning that it can happen.
I don't think it can happen. No, I don't know of anyone researching, how to turn microchips into liquid and then being able to monitor people. I just think that, it stems from like a sci-fi type era of people like, seeing movies and things like that, and then being concerned and being weary of what's actually in the vaccines. But every company actually has a detailed list of each of their ingredients that you can find on their website. That's one of the videos that I'm going to hopefully be doing next, is discussing all the ingredients. Microchips are not in the ingredients, so we can clarify what people are getting when they get a vaccine.
Okay. As a scientist as well.
Yeah.
Okay, so I know you say that there's a list of all the ingredients and everything that will be in the vaccine, but don't you also think that there are certain things that might be hidden and it doesn't need to be said? As a scientist, is it everything you release out to the public that these are the things in whatever we're grooming? It doesn't have to be vaccines, but it could be anything else. So is there, let me get you to respond to that.
Yeah. So, as a scientist, we definitely need to list everything that we're doing and the protocols, like the procedures that we're doing in order to, for the experiments that we are currently conducting. Because if we want to publish this results and we want these results to be, in good journals, and we want them to be reproducible, we need other scientists that are not in our area to be able to do the same exact experiments following our notes. And if we're trying to hide something, or we are putting information in there that are not in our notes, and somebody tries to do it and they fail, they're going to say, well, what did you do different? Because we can't repeat what you're doing. So definitely maintaining like good notes, and being able to have the correct procedures and ingredients at the accurate concentrations and times that you will conduct these experiments is very important at the scientific level. So, in the fact of trying to like hide something in there, of course, I can see people's concern of that, definitely. But it just wouldn't be possible for another scientist to reproduce what they're doing if they were trying to hide something.
Okay, because there's the aspect of the economics side of it, like it's about businesses. There's the argument as to pharmaceutical companies are going to go into extinction if they don't make money from, pharmaceutical products. So they also want to hide certain things so that nobody else can replicate it and then start to make money off it. So where is the economic side of this conversation going now?
Yeah, so I'm not too sure about the economics related to the pharmaceuticals, so I can't speak too much on that. But I do know that I'm pretty sure it was the Oxford AstraZeneca has, they've confirmed that they are willing to give out X millions of doses, and I think it was either free or at a very low charge, because they want to help, stop this pandemic. So at least in the, I would need to, look at an article and like see what their actual numbers were that they gave, but they mentioned something like this. So I think that the money making from some of these places is not as, they're not looking to do it as much, because actually they've received the money already. So a lot of these places received money to design the drugs or to make the drugs to make sure they're safe in advance, where before, if you have any other type of drug that you get, maybe if you have diabetes or you have high blood pressure or you have some other type of sickness, the company had to invest their own money in order to make the drugs. And then now they have to sell it to make their money back.
I see. So that was something, I'm so happy you raised this up, because I had a talk with, a friend of mine, and I was saying, why is there such a big deal over people making money and all of that regarding the vaccine? And and I was trying to relate it as well with other diseases as well, because there was this post that started going out like, oh, we've had cancer for years and years, and they've been trying to get vaccines. Nothing has been done about that. And then suddenly COVID-19 just pops up. And then in less than how many years, or less than a year, or about a year,
Yeah.
it just comes out. And one of the things he said to me was that because it's a pandemic, it's literally affecting everyone. And
Yeah.
as opposed to maybe cancer or diabetes at a certain group of people, and then it would now be like what you said, the companies wanting to invest in it. So yeah, I guess you might not be the best person to ask about the economics. I get that.
Yeah.
But it's just interesting to know as well that these are the different things that could, make people feel differently regarding this vaccine. I've got a question on Facebook, and I'm going to put it up for you, and it's by Kabiru Abbas, and he's saying that, is it safe for a pregnant woman to take the vaccine? Will it have any effect on the baby?
So that's another great question, because there has also been some propaganda relating to women's fertility related to the vaccine. And I don't know, across other countries, but in the United States, the Society for the OBGYNs has stated that it is safe, and they do recommend for pregnant women to take the vaccine. It's safe for both the mother and it's safe for the baby. Actually, the baby gets its antibodies from the mom. So any protection that the mom has, the baby is going to now have that protection. So it's actually a great way to give your baby protection against this virus that's now going to be coming into this pandemic. And the concerns with I don't really want to say what the propaganda was, because it's not true, but there was concerns that, it would maybe make a woman not be able to have a child in the future. And there's no data that supports that finding. We've seen that there have been millions of women infected with SARS-CoV-2 during these past several months, this past year, and loss of pregnancy has not been associated with any of them in terms of, the ones who have survived. So if they survived having COVID-19, they actually should have antibodies against the virus. Sometimes those antibodies are not very much, sometimes there's a lot. It just depends on how much you were infected. But the women who have survived, they have not reported any infertility that has been associated with them as a side effect of having the virus. So the vaccine wouldn't be able to do that either. And then one other statistic that I think is important for women to know who are pregnant is that the pregnant women are actually more susceptible to diseases and viruses and infection that could make them sick and their baby sick. So they're already they're already at a higher risk of dying from COVID-19 or from being infected. So the vaccine will only help to lower that chance of being infected and having an adverse effect that could be life-threatening for both.
So, but presently, we don't have the vaccines available for children. It's just the ones being produced right now are for, if you could just confirm what they are for, or who they are for.
So they're for individuals that are aged 18 or older. They have to do separate clinical trials that involve, different procedures in order for the younger population. So right now, it's only approved for 18 or older, at least in the US and the UK. I'm not sure how other countries will handle the age association, but but they are ongoing right now, looking at how effective are these vaccines for the children.
So let me ask this question. So I'm constantly having to respond to people within my sphere regarding the aspect of the vaccine being a cure, the vaccine being a preventive measure. Even if you take the vaccine, it doesn't mean that you are not going to infect somebody else again. So it's like, okay, what's the point in us taking the vaccine? This COVID-19, yes, has killed thousands of people, but it's not as bad as other diseases as well. So there's certain questions that are being asked, and they go like, well, yes, it is a pandemic, but the way maybe Africans respond to these diseases, you're not having as many people die in Africa as opposed to other countries. And so why are we being made to consider taking, these vaccines? So it's still part of the questions, like having to,
Yeah.
break down everything.
Right.
But do you feel though that we are going to get to a point where traveling, for example, if you do not
Mhm.
take these vaccines, you're not going to get to travel to certain countries. And then you now have Africans feeling like, well, you are not forcing us to take the vaccine, but you are putting measures that would, at the end of the day,
Effect.
force us to take it, and we don't want to have to take it. So, I
Right.
mean, what can you say regarding this?
Yeah. So I will say, the vaccine is not going to cure the SARS-CoV-2. What the vaccine is just, an additional protective measure, which I know you had mentioned. So you can think of it like if you're driving a car, the protective measures you like to do is you'd like to wear your seatbelt, you try to follow the speed limit, you don't get too close to other cars. This is another one of those safety measures that we're trying to do in order to stop the spread. We're trying to wear our masks, we're keeping our distance from other people and getting a vaccine. All of these things are helping to stop the spread of the virus because the virus can only survive in another person, a different
Yeah.
host. It can't survive on its own and continue to grow. So, you know, what the goal for the vaccine is to vaccinate enough people where we can get this virus out of the community so it's
I
not
see.
infecting other people.
Mm,
You don't need to vaccinate everybody in order to get that to happen. There's a term called herd immunity, which I'm sure you might have
yeah.
been seen floating around, basically meaning that enough people have been vaccinated that it creates a bubble around those people who haven't been vaccinated to protect them. And the
Okay.
virus, it's trying to get in, but every person it tries to get into has antibodies and it gets killed, so it can't continue to spread.
Yeah.
Um, and that's going to take several months, or maybe a year. Who knows how long it's going to take to vaccinate enough people? But as we continue to lower the spread of the virus, and then the
Hmm.
more people that have antibodies, or the more rules we can follow to limit its spread, then I think the closer we'll be to getting back to more sense of normal and typical travel. But I do know, people have still been slightly traveling, especially, people that are need to do that for their work, people who need to do
Yeah.
that for their families. And they do have measures in place in order to make sure you have a negative test, to make sure that you've quarantined. So there are ways that you can still be safe, even, if you don't get the vaccine. But um, I just think getting
But
the
you think
vaccine
it's
just
going to
provides
get
that
to,
extra.
yeah.
Oh,
But do you think it is going to get to that point where you
you
have to
have to
take the
take.
vaccine?
I don't think it's going to get there. I don't think it will get there as long as we continue to stop the spread by following other measures in place. But
Mm,
if it continues to grow out of hand, if it keeps, we don't know yet some of these mutated forms that
exactly.
they say that they're more contagious. The antibodies hopefully will still be able to destroy them, but we just don't know. So, like, I think that's data we're going to find out in the next couple months, and then pending on those mutations and how effective they are, that might direct the question to
Okay.
more of a you need to take rather than you should
You
take,
should
or
take
we're
it.
encouraging to
Okay.
take it.
I see. So are you, so meaning that, because my question, I think you've kind of like answered it, meaning that the fact that you take the vaccine right now regarding the COVID-19, virus, even if there's some mutation that could take place later on, um, you're still safer towards
Yeah.
that one as opposed to
Yeah.
someone who hasn't had it.
Anything. Yes.
Okay.
Yes.
Okay.
Yeah.
Okay. Well, that's a good one. The reason why I asked the question about whether it's going to get to the point where you have to be forced to take it is because, for example, recently I traveled to South Africa, and before you
Mhm.
can go to certain countries, anyway,
Okay.
some of the countries you need to provide your yellow fever card.
Yes, I have that
Yeah.
too. Yeah.
Oh, you have that. Good.
Yes,
So if
yeah.
you can't even apply for a visa if you don't have
Right.
that.
Yes. Yep.
So people are already feeling like, oh my goodness, I'm not too comfortable with the COVID-19 virus vaccine because I still have several questions to ask. But what if it gets to that level where it's like yellow fever, where it's like you have to take it? No one is forcing you to travel to South Africa, but if you want to
That's
go to
true.
South Africa,
Exactly.
you
Yeah.
need to have
Yeah.
that vaccine. So it's just a question people have right
Yeah.
now. But anyway,
I
Rob,
think
it's a
that was a perfect comparison. I love that. Yeah.
awesome. So it's 6:59 where I am, and I'm thinking it's probably 12:59 at you as well.
Yeah.
And I think I've had fun. It's been lovely
It
having you on board.
yes, I had a blast. Thank you.
Is there anything you want to say, something you haven't raised before that you like to say now?
Just if anyone has questions, leave them on the post that Angela will put up or on Twitter, and I'm doing my best to try to answer, as many questions as I
Question.
can, as as people have them, because I want people to feel safe about it. And it's okay to have questions. It's okay to know your body and try and figure out what is best for you. Don't think that you don't feel that you should not be asking questions just because other
Great,
people aren't. Definitely. Yeah.
great. Awesome, Rob. I'm thinking that we need to do another session of this, maybe sometime later. I hope
Yeah.
that would be
I would
fine with
love
you.
that. That would be awesome.
Awesome. Thank you, thank you, thank you so much. I think we're having more comments just coming through. I'm putting it out. Kabir is saying excellent discussion. Thank you. We have Sean Onokoya saying awesome discourse. Well done. I have Kabir. Okay, that's Kabir's question about pregnancy, which we've answered. Kerry W. Moore is saying amazing explanation. We have Sir Charles saying, not wonderful, knowledgeable, thank you. Also, it's God bless you to everyone who commented. And of course, watching this video right now, we appreciate you. What we'll just keep doing is asking more questions, and hopefully, Rob will get to answer our questions.
Yes. Yeah.
But Rob, have you been vaccinated?
I have not been. So I'm not available yet. Right now in my area, it's only going to the frontline medical workers first. Then it's
Yeah.
going to go to people who are over 65 years old and
Yeah.
have some sickness, and then I'll be in the third group. So I think I'm predicted to get a vaccine right around March,
March.
which is my birthday. So it might be a good
Oh,
birthday
okay.
present. Yeah, I would love a vaccine as a birthday present. So we'll see.
That time to have another conversation and ask you, how do you feel right now?
Yes,
Haven't had
yes,
it.
yes, definitely.
Awesome. Thank you, thank you, thank you. So, Rob, I'm going to be taking you out of the studio. God bless you, and thank you
Sounds
very much
good.
for being a part of this. Take
Yes,
care.
thank you.
Bye.
Bye, everyone.
Bye. Okay, and that's it from me to you. I'm so happy. You have no clue how nervous I was anyway, having this conversation, but I'm really, really happy that we got to do it. And this video is, of course, going to be posted it's going to be on the page, on the Facebook page, Twitter, and we're going to put it as well on the YouTube channel that we have, which is Across Borders. So you can get to watch it and share it. If you've got more questions for Rob, please remember that you can follow him on at Scientist Swanda on Twitter, and he's also on Facebook as well, right? So just search for him, you'd find him there, and it's really cool person. I'm sure he'd respond to all of your questions. So I think a comment came through. No, it's not a comment. It's not a question. Yeah, it's a comment. And that is from Akwan Zainab. Thanks a lot, Angela. Really helpful. I'm happy about that as well. So from me to you, wherever you are, stay safe. Remember, wear your mask, wash your hands. And let's just hope that this madness that we have as a pandemic would go away sometime soon and we can get back to our normal lives. But again, people are saying they're not sure we're ever going to get back to our normal lives, that this is the new normal. But however it is, please let us try to stay safe. So I'm going to be letting you go right now. Thank you so much, and God bless you. Bye.